Okay, let's go. So, yes, this is another question. Can someone tell me which one is going to be a solution there? Can you guys check quickly? Anyone can check? The one who gets it first, I'm happy.
It's 1, sir.
Still 1. Wow, that's nice. So x is equal to 1 will be a solution. Maybe that's actually worth noting it. But x minus 1 would be a factor. So if that's the case, it basically means that, you know, if you were to take that x to the power 3 plus x squared plus x minus 3, and you actually sort of like, you know, one of its factors would be x minus 1. And we kind of know from doing difference of cubes and sum of cubes that the solution is always accompanied by a quadratic. If you have x minus 1, then you're going to have a form of a quadratic here, plus bx plus c. So we know that it takes that general form of a quadratic. So, but we say that we want to know what is this quadratic going on here. We want to know what is this guy. You know, we want to know what is this guy. So we're like, okay, you know what? I'll actually write it much more clear this time. We can say we will divide these. We will divide these both sides by x minus 1. X minus 1, and as a result, that would cancel that. And we have to do this division this side. So we kind of know that that division gives us ax squared plus bx plus c. So actually doing that division becomes very necessary if we care about that this quadratic that we get this side. See, Vanana, are we understanding each other?
Wait, sir.
Yes. Yes.
Where do we get our x to the x? Where do we get our x cubed plus x squared minus x minus 3? Where do we get that? Because it looks like
it's our actual.
Do they like give it to you?
No, was you trying to factorize this, Miss? So when you were guessing, you were using that.
Wait, what are we trying to factorize? So wait, I want to know, where does that come from? Do they like give it to you, or is it some?
This could be, oh, let me actually give, you were not here in class. So like, for instance, let's see. This could be a function. This could be, do you see this function? This could be a function, right? And you could be interested in the x-intercepts. And you normally say for y-inter, let f of x be equal to 0, right? Because you care about your x-intercepts, right?
Yes,
and then that's where that guy could be born, for instance, because now this is what you'll start having. That's what you would have, which is these problems that we are trying to solve now. Are you following?
Please say that again, sir.
This is actually a function. And let me just put it to the right. This is actually a function. You know, this was a function, x equal to 0. But because you want your y-intercept, because you want your x-intercept, you let y is equal to 0. So that's why you end up having this x cubed plus x squared plus x minus 3 is equal to 0.
So basically, like they give you it's
Yes.
like the function that you were given. So
Yes.
it could change any time, sir.
What do you mean?
Like it won't always be x cubed plus x squared plus x minus 3 is equal to 0, right?
Yes, we've had different functions. The function that we have here, it's
Oh, okay.
it's different to the function that we have here.
Okay.
And it's different
I
to,
just
so
wanted
these
to
are
know
different
that.
examples. And it's different to that function.
Okay. Okay, so I understand. Thank
Okay.
you.
That's good. That's good. Guys, anyone who have things that they don't understand, it is likely that you're not the only one who doesn't understand. So asking clarifies a lot of things. Any questions? This is the last example. Okay. So anyway, if there's no questions, then that's where we are at. And again, we will just do our long division. We'll do our long division and is someone trying to ask a question?
Yolanda is trying to say something, sir.
Oh, okay. I'm struggling to hear Yolanda. Actually, I haven't heard her. Can she type? Can she type her question? Is it possible that she types a question? Yolanda, can you type a question? Unless you literally just can't hear me as well, just altogether. Guys, can someone talk to Yolanda and get a sense of if she can type her question? Okay, meanwhile, I will continue. Okay, so yes, so what is being divided would come under this. So now you will then do that. So you'll say, in fact, is there anyone who thinks that they don't understand this, but they probably just want to give it a try themselves? Is there anyone who doesn't understand what we've done from the previous problems? Okay, no one. So can I pause here? Can I not do this problem? Can people do this problem and then send it to me? Okay, so people are going to do that. Now let's move on. We're moving on now. We're moving on.
Sir,
Yes.
we cannot move on. You were doing this example for me. I said
Oh,
I
yeah.
didn't understand what you were doing in the previous example. So
Oh yeah,
this example
you
was
should have
for
said.
me, so
Okay, cool. Anyway, let's go. Let's go. Okay, so you take this guy, or maybe your focus should normally be on this guy. This is what you're dividing everything with, right? So you would say x cubed divided by that x, right? Which is this guy divided by that. You get your answer. That would be x squared. You will have it over there. You then take that x squared, you multiply it with this x, you're gonna get an x cubed over here. That x squared, you actually multiply the whole entire bracket, so you also do the -1 as well. So you'll get that. Put brackets, subtract, and there you go. And then you have your division line over there. The x cubes are gonna go to 0. This minus will multiply inside, you would have a plus x squared. So altogether you will have an x squared when you add them. And that was the first iteration. Are we happy?
A 3x squared, sir.
Oh, that would be 2x squared. My apologies.
Yeah, I'm like,
Okay. Are we happy with that?
yes, sir. I'm happy so far.
Pull these guys down. That was your first iteration. You pull these guys down, you would have a plus x and a minus 3. Then you start with your second iteration. You go to that x squared, 2x squared, you divide it by x, you will have a plus 2x. You take that plus 2x, you multiply that x, you multiply that negative 1, you will have a 2x squared and a negative 2x. Put your brackets, you subtract, this would be 0, and then that would be 3x.
Excuse me.
Yes.
Where do we get this 2 minus 2x? Is it x
2
plus 2x? Is that how we got our 3x?
Yes, because this negative multiplies with that negative, so it's positive, and then you add your x and your 2x.
Okay, and then here we have a 2x divided by x. Balance me here. How do we get this 2x here at the top?
So you say you take this guy, you take this, and you divide it by that, and then you get that 2x. You take that 2x, you multiply the whole entire bracket, you get the 2x squared minus 2x, and then you put brackets, you put a negative there.
You say 2x.
It's fine. I'll start it again just for you to make more sense of this. So
Okay.
you will take this guy over here, and divide it by your x, the green one. The answer that you will get there is 2x. You put it here, right? Now you have that answer, you multiply it by the whole entire bracket. And then what you would then have from that bracket is 2x squared minus 2x. You put brackets and you subtract. Put your line, and then you do that negative, that 2x squared minus 2x in the bracket would now become minus 2x squared plus 2x, which would give you 0 for your first addition, but your second one would be 3x. Are we happy?
Yes, I am.
And then we pull this down, which is going to be minus 3. That was your second iteration. Your third iteration now, you take this 3x, you divide it by your x, you get what? A positive 3. You take that 3, you multiply it by the whole entire bracket, and then you're going to get a 3x minus 3. And then if you put a negative like we've been doing, you will get a 0. Then that also means that in this division, the remainder is 0. So it means that that x minus 1 gets into that thing under the radical, and then the pinkish thing is what is left. So what does this mean? This basically means that you have x cubed plus x squared plus x minus 3 gives you what? It gives you x minus 1 and x cubed plus x squared plus x minus 3. Are you guys following?
Yes,
Okay, that's the end of things.
So, sir,
Yes.
okay, with my understanding, are we going to divide everything by x minus 1? Like basically with every function that we get, that we must like do something like that, we must factorize. Are we going to
It's not
try
going to
and
be x minus 1. It's not going to always be minus 1. What makes this one x minus 1 and this is bad examples because they all have x minus 1. It's because the first
Yeah.
solution that we got was that. So I'm sorry, someone is knocking on my door. Okay, thank you guys. So it's not always going to be that, but nothing much changes because it's always going to be x some, not a, maybe not, that's, yeah, probably it's always going to be x something, but it's not, for instance, if you think about the solution that we got, let's go back. I think the second one, let me see the second one. The second one would have been, just check quickly. The second one, was it the first solution that had minus 2's? No, the first one had minus 1's. So it must be the second one. Yes. So do you see in this, we have x minus 2. So if someone wouldn't have tried, when we're trying to get solutions, if they wouldn't have tried the x is equal to 1, and instead they have tried this one, their factor would have been different, right? So their factor would have been x minus 1. I mean, sorry, x minus 2. That would have been their factor. Are we following? And then the division you would have been dividing by x minus 2. But that doesn't make any big difference, because if you think about the -1, doesn't do much work. It's not as involved as the x itself. Okay, are we following each other?
Yes, you are.
Okay, thank you. Thank you, guys. Now getting into the deep calculus, Anyway, let me take this time just to analyze things. What's happening with my pen? Sorry, guys, my pen is running away from me. What's happening here? Okay, now let's take a look at a cubic function. So a cubic function, wait, what's going on? A cubic function would, let's take that Cartesian plane. Cubic function can have, or maybe, can have two forms, an increasing one, or maybe like a one that looks like that, or that happens when, okay, maybe let me also just state the equation of the cubic function. It's ax cubed plus bx squared plus cx plus d, so you can have that one, an increasing one. That's when a is greater than 0, and you have this one when a is less than 0. I normally started drawing that one, but it does this. Yeah, so you can see it starts with a negative slope, whereas this one starts with a positive slope. So yes, now what we're going to be looking at in this chapter is drawing these functions, is being able to draw these functions. So we're actually going to take these functions that we've looked at and we're going to draw them. So if you want to look just in a general function, what's going to happen, it's going to look like this. We have few points that are quite very important to us. We have these points, which we call our X-intercepts. We know how to find them now, right? We know how to find them, so they are not a challenge anymore. This is what we've been doing so far. And then we have these guys over here, that guy over there, it's the Y-intercept. And then we have another point, okay. And then we have this guy over here. You know, these are our turning points, which are very important, right? So I will take one of these functions and I will draw them and I will talk about what's going on. So I just want us to talk about this. If you think about what's happening at the turning point, the turning point has a flat gradient. The gradient there at the turning point is flat. No, it's a flat gradient. And the turning point over here, it's a flat as well, both at the turning point. If the gradient is 0 at the turning point, what can you say about the derivatives of the functions?
Where X.
The derivatives
They are constant?
not quite.
No, not.
So you have a flat line. What can you say about the derivative at that point? What
It
does
is 0, sir.
Yes, so the derivative over there is 0. So the derivative over there is 0. So the derivatives over there are 0. Now, this is a bad drawn function, but you know, not bad drawn, it's just that maybe it's not okay for what I'm trying to do. But somewhere here, there is a place where the function changes from looking up to looking, from looking down to looking up. That point, we call it a point of inflection. And, if we were to take a derivative of a derivative, what we call a second derivative, at that particular point, it would be equal to 0. So the derivative at a point of inflection is equal to 0. You can see that the function is facing down for a big part of this. We talk about that as concave down. So it's sort of like a cup facing down. So it's concave down, and on the other side, you can see it's up. So it's concave up. And we will look at those things when we are looking at the interpretation. Now, guys, I'm not going to give these ideas as like point by point notes. As I'm speaking, I will be putting these ideas. So don't wait for like a nice list where I give them. I might do that, but make sure that as I speak, you capture everything that I say. Now, I will go back into one of the functions that we've done, and then I'll actually just draw them. So let's say we have, let's take the first one. The first one, the nice one. So maybe let's take that one. It's not really a nice one. None of these are actually nice. Let me see. This one is, guys, you didn't correct me here. This here would be not that. It would be x squared plus 2x plus 3. And if you factorize that further, that would be x minus 1. And if you want to factorize these, I can see a 3 and a 1. Oh yeah, you pretty much can't factorize that. So you would leave it like that. Okay, these problems, none of them are really nice. Yes. The second one is better, but it's not ideal. Okay. I will quickly just make sure I get a nice problem. Just 1 second. Okay, maybe let me just take any of these problems. It's going to take a while what I'm doing. Okay, anyway. So let's take the first one is the beta version. Let's take x cubed minus 5x squared plus 8x minus 4 is equal to 0. Did you guys actually, can I ask, did you guys do the homework of you looking at this method before doing it in class? Did you guys do that?
Of looking at which method, sir?
Remember how I said that please just go look at the method of factorizing a cubic functions. Did you guys do that?
No, I did not do it.
That's not good because that's a homework and it's a material homework. When I give you a homework, I expect you to do it so that in our class, we don't take as much time. You know, it's fine if you've done it and you're struggling, but it's a different ball game when you haven't done it at all. And remember, we are running out of time. So we are not literally, you know, we are not on time. On our schedule, we are behind. Okay, anyway, our attempt here is to draw the function. Why did I give the function like that? Okay, it's to draw this function. So this function is given by g of x is equal to that. So we have to draw this function. Number one, we need to find the shape of the function. So we're basically going to look at the value of a, if a is greater than 0 or a is less than 0. The second thing that we would probably want to do is to look at the turning points. The third thing, probably look at the Y-intercept and the X-intercept. In complicated functions, you would look for an end behavior, but in this case, you don't have to. And that's pretty much done. After finding those, you are done. Okay, now if we look at the value of a is greater than 0, so this function is gonna look like an increasing function like that. Can you see that? So that's the first thing done. The second thing, we need to find the turning points. The turning points are the points where the derivative, first derivative is equal to 0, right? So we are going to take the first derivative of this function. The derivative of that would be 3x squared minus 10x plus 8. That's the derivative of that function. Oh, no, the function is right in front of us. That would be the derivative, 3x squared minus 10x plus 8. And then we have to take that, set it equal to 0 and solve. Yes.
Since the function is gx, doesn't the derivative say derivative of gx or something like that?
That's true. I'm just so used to this f of x. Thank you so much. So this would be 3 of x. Oh, sorry. Yes. So this would be g of x equal to 0. So we're going to have 3x squared minus 10x plus 8. Can people solve that for me? Lisa, Shana, Jenny, can you go ahead and try to solve that?
Are we solving the turning point now?
Yes, the x value.
Okay. Okay.
I will help you, just that I want you guys to work. the first X value is 1.33, or the second one is X is equal to 2. So that's the point that we've had, it's just the X values. So can I say find f of 1.33, and can Ayabukwa find f of 2? That's when you substitute back into that equation and you find what's the f value. And please note, I'm not substituting back to the gradient. I'm substituting to the actual function. Okay, actually, those values I'll actually wait from you guys, the f of 2 and the f of 1.33. Okay, guys, can I actually get the f of 1, the f 1.33? Just looked at the time.
The F2 is 0.
Okay, that makes sense, Anyana. Okay, it does make sense. I was gonna be like, no, but because I've seen the roots of the function, so I kind of know why it should look, why it looks like that. Okay, so if this is 0, and this is, so it means that these are the coordinates of the turning point. Okay, while people are still doing some calculations, the y-intercept would be when you put x is equal to 0, and you will see if you do that, this would be the y-intercept, as you've seen with the, so the y-intercept would be x is equal to 0. Therefore, if x is equal to 0, it would be -4. Can people and
So I got both answers you got by the x or x. My one x is 1.33 and the other one is 2. So I got exactly the same answers as you saw.
thank you, that helps a lot. Thank you. We kind of also know that this, this is going to be our X-intercepts, right? So the X is equal to the X minus 1 and X minus 2. Those are going to be our X-intercept. I hope, guys, we are following here. X-inter, it's when Y is equal to 0. and it's linked to the questions that we've been solving now. So I'll just give that this is going to be x minus 1, x minus 2, and x minus 2, and that's equal to 0. I just realized it's, okay, maybe let me just, so our coordinates would be x, x is 1 and 0, and we'll have x is 2 and 0, and we would have x is 2 again and 0. Now, we have all the points. We have our X-intercepts, we have our Y-intercepts. We are missing the turning point because someone had to calculate 1.33, the value of that. But we have the shape of the function. Yes.
The Y value of the 1.33, I got 67 over 10,000. 67, sir.
Okay, thank you. So, okay, in this class, I'm left with 2 minutes. So this is your homework. I want you guys to plot the function, finish it, plot it, but also up there, I want people to ensure before 8 that they send this to now. And that's it from me. Do people have any questions?
Yes, I have a question. I'm looking at do now and I'm like, what is going on here?
Yeah, you can't ask a question on it do now.
I say, okay, I'll ask my fellow classmates.
Yes. You're actually not supposed to ask anyone on it do now. It's a material that's from last time, so it's not a new material. So you're supposed to attempt, you see, that's the thing, that's bad. You are seeing the do now, you haven't tried it, you are like, what? You already have an idea that you can't do it. That's bad. Give it a try, give it a try, give it a try. Guys, I'm left with literally 1 minute here and I'll be out.
Can you scroll to the last work you just did now?
This is gonna switch off after 1 minute, guys. Just note that. Okay, guys, bye. I don't want this to switch off without me saying good night. Good night.
Thank you, sir.
Good
Night,
night.
sir.
Bye.
Bye.
Thank you, guys. Enjoy physics. Enjoy physics.